All right, so we did multiplying rationals. Dividing rationals are almost exactly the same. You have one step, and then the other steps are just the steps for multiplying rationals. So first step are keep, change, flip, because I think this is how some of y'all learned it back when you were younger. What that means is you keep your first fraction how it is. You change the sign from division to multiplication. And then you flip your last fraction. So it's now going to be 11 over 4. So we kept 12 over 7. That was our keep. We changed it to multiplication. So keep, change, and then we're going to flip 4 elevenths to be 11 fourths. Okay, so this is now our new problem, and now it's just a multiplication problem like we looked at yesterday. Okay, so all you're doing is simplifying now, right? So 12 over 7 can't simplify, 11 over 4 can't simplify, but if we look diagonally, 12 over 4 can be simplified. Okay, 12 over 4 is equal to 3, or 3 over 1. So 1 here and 3 here. And now we just multiply numerators together and denominators together. So 3 times 11 is 33, and then 7 times 1 is just 7. Okay, so the last 3 steps are exactly what we did yesterday. The first step is just keep, change, flip. Okay, so example 2, keeping my first fraction, 10n over 9, changing division to multiplication, and then flipping my second fraction. And then I'm going to simplify. So I can't simplify this way or this way, but if I look diagonally, I can simplify some. So 10 over 16 will simplify. Okay. 10 over 16, both numbers are divisible by 2. So 10 divided by 2 is 5, and 16 divided by 2 is 8. Okay. And then, so we're going to replace this with 5 and this with 8. And then 3 over 9 will also simplify. So 1/3. Okay. My ends are next to each other, so those can't be canceled out. They're both in the numerator. So we're just going to multiply them. 5n times 1n squared gives us 5n cubed. Because you have 1 n here and 2 here, giving us 3 n's. And then 3 times 8 is 24. So 5n cubed over 24 is our final answer. Okay. Starting off simple, just like we did yesterday. And number 3, we have 4n over n minus 6 divided by 4n over 8n minus 48. Keep. Change to multiplication, and then flip your second fraction. Okay? And just like yesterday, you cannot just say, oh, 8n over 4n and start canceling, because 8n is being subtracted. This is a binomial, okay? You can't just cancel these out unless you had this whole thing duplicated somewhere else. But if we look diagonally here, both of these have a 4n, right? So I can put 1 for both of those. And then we're going to see if this is a binomial, so to factor it, I'm going to look for a GCF. Okay, for 8 and for 48, they don't both have ends, so I don't have to worry about that. So 1 times 8, 2 times 4. So those are the only common factors I can have, so I'm going to see if 48 is divisible by these. So is there something I can divide 40, is there a number, I don't know what I'm trying to say. Is 48 divisible by 8? Because if so, that would be my greatest common factor, right? Well, 6 times 8 is 48, so 8 would be our GCF. So we're gonna factor out an 8, okay? So I'm gonna say 8n divided by 8, which leaves me just n. And then negative 48, let's see, I'll write it over here. Negative 48 divided by my GCF of 8 gives me negative 6. So then our n minus 6's cancel. Up top we have 1 times 8, which is 8. And then on bottom we just have 1. So 8 over 1 is just 8. Alright, so now we've worked up to the bigger ones. Okay. Alright, so on top here I have a trinomial. So I'm going to look at factoring that. I'm going to use the X box. So I have my A is 2. A is not 1, which means I need to remember to come back to that. B is negative 1 and C is negative 15. So A times C means 2 times the negative 15, which is negative 30. And then my B is a negative 1. So 1 times 30, 2 times 15, 3 times 10, 5 times 6. Your larger ones are going to be your negatives to keep it negative when they add together. So you're going to have 5 and negative 6. So x plus 5, x minus 6. And then you have to go back and divide by your a. If it doesn't simplify, slide your a in front. So 2x plus 5. And then x minus 3. Okay, and next, so I have another X box to do. I'm gonna run out of room. Okay, so we're gonna have A is 1, B is negative 4, C is 3. So A times C, 1 times 3 is 3, and B is negative 4. They have to multiply to be positive, but add to be negative, which means they're both gonna be negative. So I'll have x minus 1 and x minus 3. I didn't have to go back and divide by my a because my a was just 1. 2x plus 5, I would want to see if there was a GCF for 2 and for 5. 1 times 2 and 1 times 5, those are their only factors. So we just have a GCF of 1. Okay, so I don't need to do anything with that. And then one more X box to do. So for this one, A is 1, B is negative 3, and C is 2. So A times C, 1 times 2 is 2, B is negative 3. Multiply to be positive, but add to be negative, so they are both negative. So we get x minus 1 and x minus 2. All right. So I'm going to make a little extra room real quick because I am silly and I missed my step 1. Okay. So my step 1 was to keep my first fraction, so I'm going to keep it already broken down. My second step was to change or keep, then change the multiplication, and then I was supposed to flip these two. So I'm going to flip my 2x plus 5 to the bottom, and then I'm going to flip my x minus 1, x minus 2 up to the top. Okay. All right. So that was a close call, but we fixed it. All right. So I'd already factored, and then I flipped afterwards. That's fine. So kept our first one how it was, changed it to multiplication, and then flipped the second fraction. Now I want to see what can cancel out. we'll have an x minus 1 and an x minus 1, x minus 3 and an x minus 3, 2x plus 5 and a 2x plus 5, which simply leaves me an x minus 2. And that's it.